Alrighty, well, hey, Honors Chemistry. So originally I wanted to send you just 2 videos, each would be 15 minutes, but I couldn't figure out a way how to combine a couple of videos. So instead I'll send you 2 separate for each. They'll be shorter clips, and I'm going to start with this one. So I'm going to get us thinking about one of the last things that we talked about, which were mixtures and separating mixtures, and then giving some vocabulary here. So in this video, we'll talk about mixtures, compounds, elements, and how we draw particle diagrams of atoms and molecules. So we're going to start with this video, and you may want to record a couple of observations. I'm going to probably mention it as the video is playing.
In this experiment, we will first make a mixture of black iron filings and yellow sulfur powder. Black iron filings and yellow sulfur powder are thoroughly mixed.
And we've mixed iron into sand before. This is kind of like mixing iron into sand, except now it's mixing iron into sulfur. Iron is a metal, sulfur is a non-metal. And you'll see that we could separate the iron with a magnet.
A gray mixture of the two elements. This mixture can be separated by physics. For example, when a magnet is brought to the mixture, it removes essentially all the iron.
So remember, we did this in class where we separated the iron from the sand. This is just a mixture. They're not forced together. It's just 2 substances that are kind of hanging out in each other, and you could separate them physically. If I were to do something else where you'll see in a couple of seconds, about 20 seconds, if I combine them in a chemical reaction, or I chemically combine them, I really am not going to be able to separate them as easily.
Leaving the sulfur behind, which here looks gray because of the impurities from the iron. The iron has been separated from the sulfur by means of a magnet. When the same mixture is heated in a test tube, the 2 elements iron and sulfur react together to form.
Now I'm adding some form of energy to have both the iron and the sulfur to react. This is not going to be the same thing as a mixture, and you'll see that. I'm going to do something to the iron and the sulfur. They're going to combine, and we're going to call that a compound. So we'll see that in the video.
A new compound. At first, when the mixture is heated, the sulfur melts. Eventually, as the heating continues, the iron and sulfur begin to react together.
And they make what we call iron sulfide.
When the Bunsen is removed, the tube continues to glow as the reaction proceeds. The gray-black brittle solid formed is a new compound, iron sulfide. It is unlike either sulfur or iron and cannot be separated by a magnet.
So notice how it could not be picked up by a magnet. It is a new substance now. And so I want you to sketch this little particle diagram flowchart into your notebook about what's happening with the iron and sulfur. Originally, we would have covered this in class, but we're going to do this over the break. So I use different colors for iron and sulfur. Iron, I use green, sulfur is red. Remember, 2 different substances, I use 2 different colors. If I were to just mix them together, I have both the red and the green that are kind of hanging out in each other, and I could separate the green iron here using a magnet. But once I heat it up, I could do something with both the iron and the sulfur where they chemically combine to each other. This is not the mixture is not the same as the heated substance after, right? And in the end, it looks like I have the iron stuck to the sulfur, whereas before I had both the iron and sulfur separated. So this is very important to understand, and we're going to put some vocabulary terms to this. So you're going to record our new vocabulary terms for these things. So for some particle words, right? We've talked about and done particle diagrams for months now. We're going to call individual particles atoms. Atoms are the simplest indivisible unit of matter. If I have 2 or more atoms combined, we're going to call that a molecule. So these are going to be our new terms now for particle diagrams. We have atoms and molecules. Something that's very important to note is I could have two different colors for molecules, or I could have the same colors. This is going to be very important, and please make a note of this in your notebook. Do you see these three molecules here that are red, but they're all red? They are made of the same atoms, but there's two that are combined. So two or more atoms that are combined, we call that a molecule. If I have individual particles by themselves, not combined with anything else, we call them atoms. We're going to later on see that these two red atoms combined together, we're going to call them diatomic atoms or diatomic elements. We're going to call that later. Now, these are our particle words. Make sure you know this, and we'll talk about this in the future. Let's move on to pure substance words. So if I just have atoms or molecules of the same type, we're going to call them elements. Notice how both of these are elements. One is an atom, one is a molecule, but both of them individually have just one of the same color. So we're going to call them elements. This is elements of iron, and this would be elements of some molecule, maybe hydrogen, right? Hydrogen typically exists as a diatomic element. So this is an example of an element, just the same color throughout. Compounds are made of molecules, two or more different atoms composed of two or more different elements. For compounds, we need to have different colors. So notice the difference between the diatomic or the molecular element up here and the molecular compounds down here. They have different colors. So if I have two different colors that are combined or connected, we're going to call those a compound. And then for not a pure substance words, we're going to call them mixtures. So a mixture is two or more pure substances that are mixed, I should say are mixed, that are mixed but not chemically combined. Mixtures can be physically separated through separation techniques. So we've mentioned separation techniques earlier, and we've done filtration. We have talked about decanting. We've talked about distillation. Okay, so those are different separation techniques of physically separating them. These can easily be separated physically. I could use any of the techniques I mentioned, right? And notice what mixtures look like. Mixtures look like all of these different, it could be elements and compounds or atoms and molecules, and they're all different colors all around, right? So all of them have all different colors. Some of them have different shapes. We're going to keep the same shapes right now. All different colors, all mixed throughout, can be easily separated. If I were to have them mixed before and then somehow they're combined after, that would not be a mixture. That would be a new compound. This is a flow chart that is going to be very important that I would like you to record in your notebook, because we're going to have to understand how we could classify what we're going to call matter. Matter can either be pure substances or mixtures. So again, a pure substance, all of the particles are the same throughout. That's what a pure substance is. All of the particles are the same throughout. If the particles are the same color throughout, we're going to call that an element. If the particles are different colors, but all of those different colors are the same throughout, we're going to call that a compound. So this one's all blue, this one's gray and red, but all the same throughout. Now, if I throw those two together, I'm going to have mixtures. And my mixtures can either be homogeneous mixtures, and we mentioned that cherry Coke was homogeneous. It looks the same throughout, uniform throughout. If I look at it anywhere, there's no different layers. So I have different colors in here. I have molecules and atoms that are all mixed throughout. They're not the same looking, but it's going to be evenly distributed. Then I have a heterogeneous mixture, and notice how you could see, I don't know if you could try and make it out, there's clearly a layer here. I have some green and white particles on the bottom, and I have some red and white particles on top. This is a mixture because there's two different particle diagrams here, two different, we're going to call them molecules here, but one molecule stays on top, one type of molecule stays on the bottom. This is clearly split by a layer. That's a heterogeneous mixture. Okay, so we are going to move now to the worksheet. So the next video that you will see that I will make, we were going to talk about how we're going to use these notes to work on the worksheet.